Hello, hello. So in this video, we're looking at something very specific. So within geometric progressions, one of the things you might have to do is prove the sum formula. So if you haven't seen this formula here before, which is how you find the sum of a geometric series, then it's worth going back to watch our video on that first, because we covered in the previous video how to use this formula. In this video though, we're going to prove why it's like this, like we're kind of deriving it ourselves. And the question will look something like this. Prove that the sum of the first n terms of a geometric series is given by this formula. So, how do we do that? Well, there's basically a very set series of steps you have to follow. You can't really deviate from them, there's no really other way to show it, you just have to memorize all these steps. Which is kind of a pain, but the idea is if you understand why the steps are the way they are, then it's a lot more easy to remember. So that's what we're going to try and do today. So if I just scroll down here, I've already written out all of the steps, and I'm just going to try and explain why they are the way they are. So the first line here is just writing out the sum. So the sum of the first n terms is all of these things, and these you're just kind of writing out the terms in algebra. So the first term is a, that's literally what a means. Second term would be a times by the common ratio r. Third term would be ar squared, and so on and so on. Yeah. And then we could do this kind of going on forever, but the second to last term would be a times r to the power of n minus 2, and the very last term would be a times r to the power of n minus 1. Yeah. So that's just how you'd write out the sequence if you're kind of writing them all out in algebra. Then we do this weird thing where we multiply everything by r. So you can see I put an r here on the left. So I multiply my Sn by r. I also multiply a by r to get ar, multiply ar by another r to get ar squared, and so on and so on. So basically this row is the same as the top one, except every single term has been multiplied by r. Yeah, that doesn't really make any sense by itself, but it will make sense while we use it in a minute. But that's what you do. So you write out these. Then the important bit is you do this one, take away this one. So you can see I've got like Sn, which is this bit here, take away Rn, this bit here. So we're going to do this whole first row minus this whole second row. And the important bit here is what happens when you do that. So if I do this row, take away this one, you see I've got an AR here. This AR, take away this AR, would cancel them both out, wouldn't it? This AR squared, take away this AR squared, would cancel those out. And so on and so on. Because I haven't done all the terms, it doesn't quite go perfectly. But basically, all these other ones would cancel out. Apart from AR to the n. That's the only one that wouldn't cancel out, along with A. So, Sn minus Rsn actually ends up with just a minus a to the power, or a times r to the power of n. That's all we're left with once we've cancelled everything out. So now we've got this equation, and then we can factorize them both. So from this one, take out the common factor of Sn. So we've got 1 minus r in the bracket. Yeah, this is just this here factorized. And then for this one here, we just take out the common factor of a. So that gives an a on the outside and a 1 minus r to the power of n on the inside. Yeah. So far we found Sn, found Rsn, taken away Rsn from Sn, and now we factorize them both. And the very last step is we divide both sides by this 1 minus r. Because remember, we want the Sn by itself, that's what we're trying to do. So when you divide both sides by 1 minus r, it gives you this. And that's literally it. That's the formula. So in a way, it's really difficult. Like if you just try to memorize all those steps, it is hard to remember. But all you really need to remember, in my opinion, is this bit here. Yeah, just remember this. As long as you remember that you're going to have to do Sn minus Rsn, the rest of it kind of follows. Because you know you need Sn, so you start writing out all this row. you know you need RSN, so you start writing out all this row. And then you do the subtraction, and you'll end up with just this. And then you just remember to factorize. Okay, so maybe you could remember to factorize as well. And that's going to give you this, which is then quite easy to turn into this, the actual thing that you want. So this here is the main thing you'll remember, and that's kind of it. I don't know if you've watched the video already on proving the arithmetic sum formula, but it is similar in a way. When you prove the arithmetic sum formula, we write out Sn, and then we kind of reverse it and write out the other way and add them together. So it's a little bit different, but there are analogies. So now that you've watched this, if I were you, I'd go away and try write it all out yourself. Maybe try write it out a couple of times to make sure you've got it all right. And then maybe go back to the arithmetic sum proof video and try do that one. And if you see how they're similar, it'll actually help you remember them both. Because otherwise, people often get confused between the two. And that obviously makes it a lot harder to remember. So anyway, I hope this all made sense. The main thing here is just to remember this bit and just write it out a few times. Maybe try to explain it to a friend. Even if they don't understand maths, just explain it anyway. Because if you can explain it to somebody, then that means you understand it. But yeah, if you've got any questions, let us know down in the FAQ. And I'll see you in the next video. Thanks.